Hello everyone. In this lecture, I will explain the relationship between discrete Fourier transform and Z transform. By definition of Fourier transform, ft of x of t equal to integration of minus infinity to plus infinity x of t into e to the power minus j omega t. And for discrete Fourier transform, DFT of xn equal to summation of n equal to minus infinity to plus infinity x of n into e to the power minus j omega n. And by definition of Z transform, x of z equal to summation of n equal to minus infinity to plus infinity x of n into z to the power minus n. Or x of z equal to summation of n equal to minus infinity to plus infinity x of n into z means r into e to the power j omega minus n, or x of z to the power minus n, or x of z equal to this is the discrete Fourier transform of x of n, DFT of xn to r to minus n, or inverse discrete Fourier transform of x of z equal to x of n into r to the power minus n, or x of n equal to r to the power n, inverse discrete Fourier transform of x of z. Or r to the power n. And from the definition of inverse discrete Fourier transform, we know that 1 by 2 pi into integration of x of z e to the power j omega n into t omega, or x of n equal to 1 by 2 pi integration of x z r into e to the power j omega n into d omega. Now let z equal to r into e to the power j omega. Differentiating both sides, we get d dd omega of z equal to r into e to the power j omega to z, or d omega equal to dz by r into e to the power j omega into z, or d omega equal to dz and into e to the power. That means x of n equal to 1 by twice pi integration of xz into z to the power n dz by z into z, or xn equal to 1 by 2 pi j into integration of xz into z to the power n minus 1 into dz. This is inverse Z transform equation. Here's the lecture. Thank you.